So thank you everyone for joining us. Let's start. I first of all I invite Dr. Bhaskar to give welcome address and invite welcome all the speakers on board, and then we'll start. So Dr. Bhaskar, over to you.
Good afternoon, everyone, and thank you so much for joining us this afternoon for this session on cooling innovations in the HVAC sector. And we are indeed looking to understand some new pathways for enhancing energy efficiency in this sector. Most of you are perhaps familiar with the Alliance for an Energy Efficient Economy, but just for some of those who may not be very familiar, just two lines. The Alliance for an Energy Efficient Economy, in short, referred to by most people as AEEE, is an industry-led body which advances the cause of energy efficiency and works to ensure that energy efficiency is fostered as a culture in everyone's daily activities. We have representatives from the industry, from the civil society organizations, from research organizations as part of our members. And we do have these sessions on knowledge exchange very, very regularly to share the experiences and expertise that is available both with the members as well as with people who have worked to advance energy efficiency in the sector. Most of you perhaps are aware that the India Cooling Action Plan, which has become a kind of a Bible as far as the cooling sector is concerned, was taken by the Ministry of Environment and Forest 4 years ago. The AEEE did play a key role in bringing together all the stakeholders to put together this very document, which has identified the growth possibilities in the HVAC sector, considering the fact that India's penetration of HVAC is still very, very low compared to several other countries. And at the same time, identifying a set of actions that needed to be taken by all the key stakeholders, not just the government institutions, but also the private sector and the civil society organizations, to advance energy efficiency with a view to bringing down the demand for cooling in the country. And in this respect, as all of you again are perhaps aware, with the India's installed capacity somewhere around 425 gigawatts, expected to almost double in the next 10 years, cooling load taking up anywhere between 30 to 40% during peak time, cooling indeed becomes an important part as far as the future projections are concerned. And it is in this respect that AEEE has been working with stakeholders to see what we can do to reduce the demand for cooling as far as India is concerned. Today, we have some very exciting presentations from three key people who have been making wonderful advances in the HVAC space. We have the CEO of Hydromx USA, who's going to be speaking to us. We have a specialist from Plus Advanced Technologies, and we also have a senior person who's an expert in the AC field from Eurovent. I'm sure all these three presentations will be extremely useful to all the people who have joined us here. And I'm requesting everyone to interact with these people and also to keep in touch with AEEE to be aware of the various changes, advancements, and progress in the HVAC space. So therefore, once again, I extend a very warm welcome to all the participants who have joined us today, and to the three key speakers who are going to be here sharing their knowledge and experience. And therefore, now I will turn over to my colleague Santosh to give a brief presentation on setting the context for today's meeting. Thank you all, and over to you, Santosh.
Thanks, Bhaskar. So I'll share my presentation. Uh,
स्क्रीन विंडो टैप करके ना एंटायर स्क्रीन शेयर कर नहीं एंटायर स्क्रीन प्रेजेंटेशन
What is slide view?
so I hope I am audible and my screen is visible to you all. If you
Yes, you are.
have that they are not able to hear, so they can rejoin if they are unable to join, unable to hear that. I'll start. So what is the importance of HVAC systems and energy efficiency in the HVAC system? So like when it comes to finding the energy efficiency or the potential of energy efficiency in HVAC systems, we talk about few circuits, technology, components, equipments in the HVAC systems. But before that, like what is the role of the HVAC system in our life and how it will affect, it is affecting the current scenario in the energy efficiency. So the objectives of the HVAC system is to provide thermal comfort in the buildings and better improved indoor air qualities. Along with that, the HVAC system consumes a significant amount of energy in buildings, like 40-50% of the total building energy consumption. So it is important to talk about the energy efficiency, like how much we can save, because it is directly related with the operating cost, operating bills, and the environmental emissions as well. So in India, with a population of about 1.35 billion people and having a tropical climate, so about 3,000 cooling degree days per year, India's total cooling demand is about 3 trillion cooling days, which is 4 times and 15 times higher than China and the USA. The cooling market is growing with a CAGR of 8%, which would reach by $44 billion by 2030, and have potential of 45% of energy saving by installing the energy efficient solutions in the HVAC system. As per ICAP, India Cooling Action Plan, which aimed to reduce the cooling demands in building sector by 20 to 25%, and the energy consumption by 24.5 to 40% by 2037-38. When it comes to finding the energy efficiency, we have to understand how the HVAC system works, what are the components involved in it, and the various equipments working, the loops, the heat transferring fluids, etc. So, the core of the HVAC system is the VCR system, or vapor compression refrigeration system, where the refrigerant is compressed and the heat is extracted to the ambient by using air or water circuits, like in the cooling towers or the ambient air. The cooling from there is circulated to the AHUs, air handling units, depending on the climatic conditions or the reason, if we need heating or cooling, along with some filters and the blowers, fans, humidifiers, dehumidifiers, etc., as per the required comfort conditions into the indoors. So there are a lot of loops, like the water loop in the condenser side, then the refrigerant side, the water loop in the AHUs, then air handling units, and the circulation of air into the comfort zones of the buildings. So a lot of components involved in it, and huge potential of energy saving is there in various components. So I have listed down a few the factors which affect the energy efficiency or the energy consumption into the HVAC system, basically. So first is the energy efficient equipments like fans, blowers, pumps, etc., and circulating the water or the heat transferring fluids on the air, etc. The other is the VCRs, the vapor compression refrigeration system, the efficiency of it, and the advancement technology, etc., of the refrigeration system, and the heat exchangers which are like in compression condensers, evaporators, and heat exchangers in the air handling units, etc. The other part is using nano heat transferring fluids, which because you're utilizing their thermal properties, we can enhance the heat transfer and the heat transfer efficiency in the heat exchangers. The other part is integration of thermal energy storage in terms of using latent heat energy storage or the sensible like using phase change materials along with the renewable energy integration with the HVAC systems. The other part is enhanced air distribution systems. And other is the operation of the optimized operation or the using the control variable speed drives, variable frequency drives, etc. And so all these topics are there which affect the energy consumption or the energy have the potential of energy efficiency in the HVAC systems. So in today's webinar, we will cover three topics out of it. The first one is about using nano fluids or heat transferring fluids to enhance the water loop energy efficiency or the efficient thermal heat transfer into the through the heat exchangers. So first of all, I invite Mr. Berkin from Hydromx, which will be who will be speaking on nano HTFs in building HVAC. So Mr. Berkin, over to you. You can share your slides and you can start.
Santosh, sorry to
Yes.
interrupt. I suggest you share the slides because there is some issue
Okay, that is fine.
in doing so from the US. And
We'll
I think Berkin will take it forward from his end. Right, Berkin?
Oh, I'm absolutely fine. No
Okay,
problem
great.
with that.
Thank you.
So I share.
Can you make it full screen?
Yeah, sure. So here, over to you, Berkin.
Hello, everyone. I'm hoping that you can hear me fine.
Yes.
My name is Berkin ARIKAN. I'm the acting chairman and CEO of Hydromx Technology. I reside in New York, Manhattan. It's quite early here, so I apologize if my hair doesn't look good, you know. So I guess we can start the presentation. I don't know who's changing the slides. Maybe Mr. Mahan, if you can please. Next slide, please.
Yeah. So Mr. Santosh is the one who's running it for you. Thank you.
Okay. All right. If when I say next slide, please go on to the next slide. But no, not now.
Yeah.
Just, okay. I apologize
Please
for
go
this.
back. Santosh, can you go back to the previous slide? Thank you so much.
Thank you. All right. Obviously, this is not my first rodeo. I'm going to use some English idioms. So if you have forgotten, every time I talk about nanofluids, I'm always presenting to an audience that knows what a nanofluid is, right? So I'm going to pass the technology behind it, but I'm going to go into more detail and what makes Hydromx different and what are we doing with the technology. That's what I'm going to be more focused on, because the first question everybody asks, if this is a great technology, how come we don't find any other nanofluid in the market, right? That is the basic question I've been facing time after time. So I'm going to focus on that, and I'm going to explain why are we different from any other nanofluid company, and why are we successful in this business. Next slide, please. Next slide, please. Okay, perfect. Okay, so nanotechnology is not something we found. United States government has a patent on this technology. And the technology, you can see the patent number here, and you have the presentation, you can take a look at it. And the presentation, I mean, the patent is on a particle is highly thermally conductive. And the name of the particle is silica carbide. If you have any geologists here, they'll know exactly what that is. This material has been used in the industry in the production of sandpaper. This is this hardest material, second to diamond. Okay, so United States government patents a nanofluid to be used in HVAC industry with the hardest material on the planet that is used for sandpaper. So do you see any mistake here that they're doing? Who would use a nanofluid even though it saves, $1 zillion to you every year, but you're going to destroy your systems? This is where academia is so wrong when they look at the nanotechnology, especially in nanofluid world. This is an absolute proof of this. And this is Argonne National Lab we're talking about, and this is official United States patent. If you have time, you can go over it and you can see it for yourself. It's pretty mind-boggling. Next slide, please. In this patent, they describe how a commercial nanofluid should be, right? Next slide, please.
Santosh, can you move the slide, please? It's not moving.
So in the summary of the invention, this is a copy from the patent. This is nothing that I wrote it down. I just copy and pasted it. So if you read the last sentence where it says non-toxic, it literally describes how a nanofluid should be, right? Stable suspension with little or no particle settling, and available in large quantities at affordable cost, environmentally neutral, and non-toxic. This non-toxic comment is the summary of why you're not seeing any other commercial nanofluid out there. Food and Drug Administration in America literally controls the planet. What goes into any other product or what's not, they have the guidelines to tell which part of particles can be used in human interaction or environmental interaction or not. They have a very strict guidelines, and the executive body of these guidelines is NSF, nsf.org. So what makes Hydromx different? Next slide, please. And the reason for FDA is giving those guidelines. When you reduce a material to a nano level, it changes its properties. And this is gold, as you know what gold is. It's India, everybody knows gold. Look at the color of the gold. As you go lower than 60 nanometer in size, it changes its color. And it changes also other characteristics of the gold, as pure as it is. So FDA says, next slide, please. Even though you have your nanofluid, everything matches the without clogging, this and that. This is, again, not me saying this. This is the U.S. Department of Energy Systems. They have to get the toxicity clearance, even though you have the best nanofluid in the world. Next slide, please. You meet this. I'm going to fast forward because I know I'm limited in time. These are the main characteristics of a successful nanofluid. Next slide, please. I think one more slide, please. Okay. Yeah. Surendra or my hand forgot to unhide some of my slides. That's why I was keep repeating myself. The reason that Hydromx is available, commercially available in the market, because we cleared NSF's toxicity requirements. That's the only difference why we are available in the market. Okay, so now I'm going to talk more about what makes a nanofluid more efficient has to do with the turbulent flow and versus laminar flow. In the real world, we have laminar flow. We don't have laminar flow. Everything is turbulent, and the turbulence creates small vortexes, and these vortexes impact the efficiency or the coefficient factor of our fluid. And the particles that we are using are not metallic particles. We are protected by a trade secret provision and clause. And a lot of questions comes up every single time I bring the subject up. Oh, do you have metallic particles? No, the particles that we are using are not metallic, neither ceramic. Next slide, please. A lot of question comes up, oh, is your fluid viscous? Because when you add nanoparticles, it makes the fluid viscous. The proper measurement for a nanofluid is apparent viscosity. It's not dynamic viscosity. And apparent viscosity changes with the shear pressure that is applied on the actual real world. Imagine we do business with Empire State Building, a lot of business. And the Empire State Building, you know, as you know, is 104, 106 stories. So they pump chill water from the basement to all the way to 86th floor. So about 50 centimeter size pipes is going to a quarter-inch pipe. So that's the actual pressure they apply to the fluid, and our technology makes the fluid a shear thinning non-Newtonian fluid. So when you apply shear pressure, our fluid becomes thinner. This question will pop up, I know. That's why I bring this up every presentation. Next slide, please. These are the key installations we have in America and in the world. Virginia Technical University is an amazing case study. When they had the Ebola virus spreading out, Hydromx has been installed in a biochemistry department AI, artificial intelligence data center. And this is where they predicted Ebola virus's safe periphery. So that's like a claim to fame for us. Empire State Building, as I mentioned, we're in the 22 loops right now. And the largest boiler to heat pump retrofit project, 2 of them is currently being built. One in the Empire State, other one is again in Manhattan, 250 West 57th Avenue. The 2 large buildings, both projects been designed for Hydromx. And the company is doing this projects called Bureau Happold. I don't know if you're familiar with it, but it's a global company, one of the top 5 engineering consulting companies in the world. Hydromx is also in a Herald Square building, 1350 Broadway, entire chill water plant. Currently, we're in the 42 schools in the UK, and UK's actually government is pushing Hydromx through UK Green Building Council. You can Google UK Green Building Council space Hydromx, and you can see for yourself. In the UK, National Health System currently has been testing Hydromx in 2 chillers. And just very recently, Belgium government issued 60% for Hydromx residential installations. Next slide, please. And this concludes my presentation. Now I'm going to pass it over to Mr. Mahan Bothra. Thank you so much for listening to me and taking the time.
Thank you so much, Berkin. Thank you, Santosh, for helping out with the presentation slides. And Santosh, how much time do we have?
So 5 minutes you can also take.
5 minutes. Okay.
Yeah,
So can you then, I guess, rather than introducing ourselves, so we Galaxy Energy Solutions LLP, we have been the exclusive partners of Hydromx in India for the past 8-9 years, I guess, and we've been actively doing installations across the country, and we have some marquee customers on board. And our first customer, I guess, if I remember correctly, was the Lalit at Jaipur, wherein we had installed Hydromax in one of their hot water generator systems. And the first installation itself gave us a success ratio of almost about 30-32% in terms of savings of energy. And it's been almost 8 years now, and it still continues to do so. If you can go on to the next slide, so I'll quickly, explain a few case studies that we've done. There is a synopsis or brief on the slide, which is there. So first and foremost, one, of course, the Bureau of Indian Standards. There's a National Building Code of India, which was published, I think, sometime in 2019. And in one of the paras, they have mentioned, although it's not mandated because, the lack of, adequate availability of nanofluids, they have mentioned here that next generation fluids should be exchange efficiency based on nanotechnology to reduce energy consumption. So this is something which has already been recognized and understood as one of the measures to reduce energy consumption, at least in the HVAC chilling and heating systems. Next slide, please. These are the various certifications that Hydromax has. So most importantly, what I wanted to address, and which probably could be a concern, that anybody who's going to use Hydromax instead of water as a heat transfer medium, Hydromax does not in any way impact any material, whether it's metal, plastic, rubber, when it comes in contact with that. So it's already been certified, and the necessary certificates are available to support that. And of course, all the necessary mandatory certifications in terms of ISO 9001, 14001, OSAS, etc., is available, making the product absolutely safe and good to use. Next slide, please. We've used Hydromax. We've done close to about, I think, 100 plus installations in India, if I remember correctly. And we've, kind of worked with, when we gone to the customer's premises, so we worked with multiple, global brands. Few of them have been mentioned here, both in heating and chilling applications. So yeah, absolutely no impact whatsoever. Hydromax also runs a global insurance to protect customers' equipment. So far, there's not a single claim that has been raised from us. So yeah, it's working absolutely safe, sound, and delivering the energy efficiency that we commit. Please, next slide, please. These are a few awards that Hydromax has won. Probably the presentation is available. We can share it later on. I'll not, since lack of time, I will not go into detail. The next slide, please. Same thing, a lot of recognition in terms of, several, competitive decarbonizing technologies or, contests that Hydromax has been a part of, has been awarded. Can we go to the next slide also, please? So, okay, these are some of the installations. I'll just give you, so maybe the top, 5-10 customers that Hydromax has been installed. As I mentioned, as Berkin explained, I'll just briefly explain. So Hydromax is basically probably the only product available today which is replacing water as a heat transfer medium. It has a heat efficiency, it has a heat transfer coefficient which is almost 37% faster than that of water. So anything that a water would cool or heat in an hour, hypothetically speaking, Hydromax, when mixed with water 50-50, would do that in 45 minutes. So that's the added advantage. That's where there is lesser pressure on the hardware, so whether it's a compressor, it's a heat pump or a hot water generator, we guarantee a 20% savings. We've seen cases where it's gone up to 30-35% also, and several proven case studies. Briefly mentioning a few here, so quite a few marquee customers. We have Tata Steel in Jamshedpur, so we've installed Hydromx as a trial proof of concept in one of their Voltas chillers. You're seeing savings of more than about 25%. While we guarantee 20, we saw savings of more than 25%. We see an ROI which is probably less than 3 years. There's an installation done at Suzuki Motors in Ahmedabad. Suzuki Motors, which probably now would be bought over by Maruti Suzuki. Again, 155 TR chiller. We've seen savings of almost about 25%. ROI less than 2 years. So ROI would depend upon the energy consumption and the water volume in the chilling system. That kind of more or less reflects the ROI. As far as we are concerned, we guarantee 20%. We deliver that as promised. So, and we've seen cases where it's gone beyond that also. So next slide, please. So you got several hotels. So ITC, Maurya, of course, not just Maurya. I've got Maurya, I've got Mughal Sheraton, Maratha Sheraton, Rajputana, Taj Holiday Village, Marriott Indore. Heating, chilling, both the applications, we've seen cases, savings of 30, 25, 30, 32%. So these are the kind of saving that we see even on a heat pump, which is supposed to be an efficient equipment as far as, generating hot water is concerned. There also we guarantee a 15% saving, but we've always seen savings going in excess of 20%. Like for example, in Marriott Indore, you see the same thing. Can we go to the next slide? Honda motorcycles, again, 2 chillers, McQuay, savings of more than 20%. The Rosier at New Delhi, hot water generator, saving of almost 32%. So, yeah. Santosh, so if you have lack of time, I mean, these are few case studies. We can just move the slides. That's about it. And so thank you, everyone. Thank you, Berkin. Thank you, Santosh. Thank you, Surendraji, for patiently presenting and or listening to us. Contact details are available. A detailed presentation, explaining how the technology functions, etc., will be shared, Santosh, with you again, an updated one. And if you could just circulate it or make it available, so that everyone who's present here, or even everyone who's not present here but wants to know, it can be shared with them.
Thank you so much, Berkin and Mahenji.
Thank you. Thank you.
It's wonderful.
Berkin is here. If there are any questions, would love to.
So the questions will raise till the end of the session.
Okay. All right.
Yeah. So our next speaker is Mr. Bhuvnesh Kumar from Plus Advanced Technologies. I will save the presentation. So next, just wait. Mr. Bhuvnesh, are you there?
Yeah, I
So I
can hear
shared
you.
the slide. You can start.
Yeah, please put this on presentation mode. Hello, am I audible?
Yes.
Yeah. Yeah. Good afternoon, everyone. I'm Bhuvnesh, working as product lead in Plus Advanced Technologies. So today, I will be presenting about the PCM application in PCM use in various applications, basically. So PCM is used in a lot of areas. So today, as this webinar is about energy efficient buildings in HVAC area, so I will be presenting few applications where we can utilize the PCM efficiency to increase the overall energy efficiency of the system. So yeah, next slide, please. Yeah, so plus I will give you a little brief about the company. So company has three verticals. First vertical is life sciences and healthcare, which basically focuses on shipping solutions for basically pharma product or medical supplies. So it uses the PCM to cool your vaccines or pharma product to ship basically. Second is food and agriculture, where you have different products using the PCM, reefer truck, last mile delivery, cold rooms, and solar dryers basically. So that is basically solar powered thermal energy storage based food dryers. Third is energy efficiency. So I will talk a little bit about this vertical. Building, refrigeration equipment, and HVAC, and how the PCM can be integrated to increase the energy efficiency in the buildings and in refrigeration equipment. So Plus is a 100% subsidiary of QMI, which is a Murugappa Group company. Yeah. So next slide, please. Yeah, so for those who don't know about PCM, what is the PCM? So PCM is basically a thermal energy storage material similar to your electrical battery, where you are storing the electrical energy in form of electrical charge. But in PCM, you are storing the thermal energy basically in form of heat. So to give you an example to understand it more better, so let's take an example of ice and water. So ice is also a phase change material of 0 degrees Celsius phase transition temperature. So likewise, we have 45 plus phase change materials. So what it does, it stores the energy, and whenever you require the energy, you can extract that energy from that stored energy from the PCM. So it has basically three types of PCMs. Majorly, it has three types of PCM. One is inorganic type of PCM, second is inorganic type of PCM, and third is the foam stable type of PCM. So inorganic type of PCMs are having water and salt mixture basically. The organic type of PCMs are fatty acid based mixtures. And the third one, the foam stable PCM. So because Plus is pioneer in these PCMs since 2004, so we have this own version of PCM where your foam is not changing, although your phase is changing. Let's say your PCM is getting molten, but it is maintaining its foam into the solid form only. It is not converting into the liquid phase basically. So that is how the foam stable PCM came into picture. So this has many applications, as you can see. First is the PCM in commercial buildings. Second is heat compact battery. Third is PCM PCM integrated reefer trucks, and the final is Prongo, the last mile delivery shipping solutions basically. Next slide, please. So first is PCMs in commercial buildings. So how we can integrate the PCMs in commercial buildings to increase the efficiency of the buildings. So what are the major challenges basically before going for the solution? So one is the inefficient methods which are present in the market to heat or cool the buildings. Let's say like resistive heating or gas boilers are there, which are used for generation of the hot water or space heating purposes basically. Second is non-insulated building. So there is major heat loss or cold loss through the walls of the building because those are not insulated. So those are simple clay or cement and brick type of volt. So there is no insulation, because of which there is more inefficiency in the system. Third is electricity price surge during peak demand hours. So you might have seen like now the scenario of electricity charging has changed. The structure of the electricity charges has been changed now for some of the places in India. So how it is happening now, like the tariff for the daytime and the nighttime is quite different. And you can say like some of the time it is higher for those hours where the electricity demand is very high. So this is also a very big challenge for all the people who are running the industry, who are having very big systems running on electricity. So it is consuming a lot of energy basically. So yeah, next slide, please. Yeah, so how we can integrate it, how we can integrate the PCM. So some people outside India, what they are doing is they are having insulated tanks basically, which are fully insulated with puff and other type of insulations. And there is PCM encapsulated in balls, plastic balls or maybe metal balls. So plastic balls are used for basically the cooling purposes, and metal balls, SS stainless steel metal balls, are used for heating purposes. So you are putting the balls inside that insulated tank, and you're storing that cold energy in these balls basically by freezing the PCM which is present in these balls. And whenever there is high requirement, a high energy demand, so what you can do, you can flow the hot water in this tank, and you can extract and get that stored energy from this PCM. Whenever there is lesser electricity charge or there is less electricity demand. So there are two benefits to it. So first is like your electricity tariff, which is very high during high energy demand hours. So you are like preventing those charges which will be billing on you. So first is that. Secondly, in this system, you are using 0 degrees Celsius PCM. Or that is basically organic type of material, 0 degrees Celsius. So the people are using like water as like ice storage systems, or like you can say for thermal energy storage, they are using ice or water basically. So they have to take down or bring down the chillers to -5 degrees Celsius. So that reduces the efficiency of your compressor system, or you can say compressor condenser system. So instead of that, if you're using the PCM of 8 degrees Celsius, you have to take down your compressor to maybe 3 degree or 4 degrees Celsius only. So your efficiency curve of the compressor will improve. So that's how you will be increasing in the energy efficiency, and that will reduce your electricity bills by almost 28 to 30% basically. Next slide, please. Yeah, so this is a case study where there is a company in Ireland, Crystal Air. So they are using these systems. So they have very big tanks, which are metal tanks, insulated tanks, and they are getting 9 degrees Celsius as the output from the like tank whenever they are using the PCM in encapsulated in the boards basically. It is very modular in design. You can have very big systems, smaller systems, depending upon your requirements. It is can be customized as per the project requirements. Yeah, next slide, please. So one is as I mentioned, you can store the heat or cold in your large tank. Second method, how to integrate the PCM in your buildings or offices or residential houses. So in Europe, basically, where there is diurnal temperature variation between day and night, whenever like 15 to 20 degrees temperature difference between day and night. So what people are doing, people are putting the PCM pouches. So you can see these black pouches, which are having 22 degrees Celsius PCM, which freezes or melts at 22 degrees Celsius PCM. They are putting in the false ceiling. So during the night time, using very small capacity blower or fan, they are freezing this PCM using the outside air, which is very abundantly available. There is no charge to it. And during daytime, whenever there is high ambient and there is heat load inside the room, so this frozen PCM will be generating or releasing its cold energy and will be maintaining your room temperature. So there are few buildings in Europe which are done with the PCM. There is no requirement of air conditioners basically in the building because the PCM is taking care of all the heat load. So although it is quite difficult to like implement this kind of solution in India, because there are a very few places where there can be diurnal temperature variations between day and night. But yeah, so this could be possible in some regions in Rajasthan or other states, basically in India. Yeah, next slide, please. Yeah, so the next application where we can use the PCM as cold warehouse solution. So the name the brand name for this solution is Mass Effect. Mass Effect is basically the term coined from the thermal mass, basically the thermal mass which PCM is generating and is not letting your temperatures to fluctuate or to go beyond the required temperature range, basically. So the current scenario in India of the cold storage warehouse, it is very well known as most of the cold warehouses are owned by the private owners, and the capacity which they are using it is approximately 0.5% of the total electrical capacity which we are having in India. And people are like moving from the old technology which they had installed in 1970s or 1980s or early 2000s. So this is the current scenario. Yeah, next slide, please. What are the challenges of the cold warehouses? The major challenge of the cold warehouse is the unexpected spike. How the spike in the temperatures are happening. So there are many factors to it. One is like frequent door opening and closing during product loading or unloading. Because of that, there is major challenge of maintaining the temperature of the cold warehouse, basically. So second point is related to first only. Third is breakdown of the system. Whenever there is a breakdown or there is maintenance requirement of refrigeration system which is installed in the cold warehouses. So your product, there are high chances, there is high risk of product damage or spoilage. So that is a major challenge for all the cold warehouse owners, basically. And the last is part load utilization or low efficiency of refrigeration system. So part load utilization means like you have to run your cold warehouse at full capacity, but you are having only 50% of the product. You can store only 50% of the product. So that is also a major challenge. So Mass Effect solution, how it is, how the operation of this solution is, your PCM tabs, PCM encapsulated in plastic bottles, basically, that is kept over the racks, which are there in your cold warehouse. So it absorbs the cold energy from the abundant energy available in the air which is present in the cold warehouse, and then it stores that energy whenever there is high heat load or there is spike in the temperature. So it absorbs that extra energy or extra heat load and provides the cold energy and maintains the room temperature or cold warehouse temperatures in required range. So that's how it is operating. Next slide, please. Yeah, please move this slide. Yeah. So this is basically 3D view of like integration of your PCM tabs, PCM portals in the over the racks. So Mass Effect type of solution offers three major advantages. One is reduces dependency over your power source or grid electricity. That is a major challenge for the product owners basically. Second is peak load shifting. So whenever there is high electricity demand, so you can shut off your refrigeration system completely and can rely on your PCM bottles, and they can maintain your room temperature for like 10 hours, 12 hours, or up to maybe 16 hours also, and the efficiency increase. So there is a high efficiency increase, like you can say 15 to 20% of efficiency increase with the use of PCM, because the extra load, extra heat load is catered by your PCM. So that's how it is efficient method to integrate the PCM in cold warehouse. Yeah, next slide, please. Yeah, so the next application for the residential homes or offices is heat compact battery. So now you might have heard about the heat pumps basically, which European government has mandated to use, because earlier they were using the gas boilers, which is very cost ineffective, and it is very non-environmental friendly solutions. So along with gas boilers, you have to use the water tanks also for the storage. So they require very large space. So as you know, like there is very there are space constraints in the residential homes and the offices. So you don't want to lose on your space, right? So that is the major challenge with the current technology, which is used for the hot water or the space heating, basically. The next slide, please.
Bhuvnesh, sorry for interruption. So you have 5 more minutes, please.
Yeah, I will wrap it up. Yeah. Yeah, heat compact battery. So heat compact battery is basically used along with the heat pump also. It can be used with other energy sources as well. What is heat compact battery? It is basically an encapsulation with the heat exchanger, which is having the PCM filled inside that. So it stores the energy by if you provide the hot water, the hot water will flow into your heat battery and your PCM will get molten. And whenever there is a requirement of the heat, you just flow the cold water inside that battery, and you will get the hot water out of that. So what are the major advantages of this battery? So first is, it is like 1/4 of the size of your usual or conventional hot water cylinder or hot water tank, basically. So it can work upon any energy sources, and it downsizes your heat pump capacity also. Although heat pump is very much efficient, it is like 60% more efficient than your resistive heating systems or your gas boilers. So then also, like using the heat compact battery in combination or in integration with your heat pump will reduces the size of your heat pump, basically. It can be used for heating and cooling. It's just that you have to change the PCM grade, basically. You have to change the PCM type, which is filled inside this battery. So commonly used PCMs are 20 degrees Celsius, 48 degree and 58 degree. Next slide, please. Yeah, this is a case study of the heat compact battery. So what are the discharge temperatures, what are charge temperatures, how much capacity we can keep. So the capacity which we have built till now is 10 to 12 kilowatt, but we can go up to maybe 150 or 200 kilowatt as well. Yeah, next slide, please. So I will not focus majorly on these applications. So this is basically the cold chain logistic applications where the PCM is used in the reefer trucks to transport your ice cream or frozen items or maybe chilled items as well, like dairy products, to reduce on the operating cost, and it is a very sustainable solution and environmental friendly solution, because you are not running your compressor on the diesel, you are running the compressor on the electricity, and you're charging your PCM during the night time, and whenever there is requirement for delivering the products during the daytime, you have to just charge it for 6 hours, and you have to just load the product, and you have to take that truck for delivery basically. Yeah, next slide please. It has majorly two categories, chilled and frozen. Chilled is basically 2 to 8 degrees Celsius for dairy items or 2 to 8 degree products basically. Frozen is for the ice cream products. So this is the operation, how the operation of the PCM reefer truck is done. So you charge it for 6 hours, and your truck temperature comes down to minus 25 degrees Celsius. You load the product inside the your truck, and you can transport it for 10 to 12 hours. Still your temperature inside the truck will be minus 18 degrees Celsius. Yeah, next slide please. So these are the advantages. It is fossil fuel free refrigeration, low operating cost, low maintenance, provides carefree transportation in like whenever there is vehicle breakdown or anything happens to your refrigeration system, then also there is no product spoilage or product damage, which is worth lakhs of rupees, and it is green technology. Next slide please. Yeah, the impact is very high. So you can reduce your cost by 40%, 30 to 40%. Decarbonization potential is approximately 25 to 40% if you're using electrical grid electricity. And if you're using solar panels, so that will increase to 65% also. The payback period is 14 to 18 months. And the opportunity cost is like you are reducing your transportation costs for ice cream or any other product that will get reduced to like 1.2 rupees basically, which is currently 7.6 rupees per liter. Yeah, next slide please. So last mile delivery solution, basically these solution can be used by e-commerce companies when you order ice cream from e-commerce platforms. Like sometimes, or maybe you can say most of the times, your ice cream is molten when you get the delivery. So so that is the major challenge in the cold chain basically. So and sometimes like the commercial viability of the alternative solutions is also not that good because of the high prices of the solutions. So there is a solution to it, which is PCM integrated boxes or PCM integrated bags basically. Yeah, next slide please. Yeah, so these are the solutions basically. So first picture you can see this is of plate type of freezer, where you can freeze your all the pouches, PCM pouches or PCM bottles, and you can use those bottles in your bags or boxes to deliver your ice cream or frozen items or your medical supplies also. Sometimes vaccines are also transported in minus 20 degree or 2 to 8 degrees Celsius. Those also can be transported in these kind of solutions basically. Next slide please. Yeah, this is a cost-effective solution, hassle-free delivery, user-friendly, multiple time use. If you have taken the box, it can be used multiple time. And with one box, after charging your PCM, you can do multiple deliveries also. Like you can deliver to 4 to 6 customers at once. Yeah. Next. Next slide, please. Yeah, so Plus has got key recognition from many agencies, Virac, Cold Chain, FICCI, World Health Recognition, and also like we work on sustainable development goals only. Like whenever we are developing the product, we are keeping in mind that we have to follow the SDG goals. So that's it from my side. Thank you.
Thank you so much, Bhuvnesh, for this wonderful presentation. Our next speaker is Mr. PK Goel from Eurovent India. He will be speaking on impact of energy efficient air sites in HVAC systems. So speak it.
Yeah, go ahead, just load the presentation. Yeah, so good evening, everyone. On the onset, I would like to thank Santosh and AEEE and the previous speakers for setting up the stage so well so that I can present something called life cycle cost analysis. Why are we all here? Next slide. As you can see, the floor area in India is expanding rapidly. We still have to build most of our buildings, while as Europe and US have already done phenomenal amount of construction. We are here starting off our journey, and in years to come, we have a long way to go. At the same time, we have signed up for a lot of agreements by which we are supposed to go to net zero by 2070, if not 2050, and we need to bring our CO2 levels down. Now, if we have to do all these particular things, we have to especially look at buildings. It has been said in many forums and even yesterday that there is no decarbonizing the world without decarbonizing our buildings. So give a good look to our buildings, and you will find that of the HVAC load, which is about anywhere between 30 to 60% of building load, a substantial portion goes basically to the air side energy. We talk a lot about the vapor compression system. Santosh brought it out in his slide very well. The vapor compression system on one side, various other piping savings on the other side, and sitting there was the air handling unit. And we need to look to have a good look at these air handling units in order to make sure that we bring the energy down at the air handling unit level if we have to achieve what we have set out to achieve. And the first thing that comes into mind is, what are we going to do this particular thing? Next slide. And no, just go back one. And where are we headed? So on your screens, there are two basic lines which are shown, which show basically the kilowatt per ton or the COP of the entire plant. So what we are meaning by this is basically the COP of the chillers, or the kilowatt per ton of the chillers, where we have gone down to almost 0.6 kilowatt or even per ton or lower now. And we need to look at the overall COP of the building or the entire system, and not just the chiller. And in order to reach that, we need to make our pumps more efficient. We need to make our cooling towers more efficient. We need to make our air handling units more efficient. So what you see on your right-hand side, although we are at a reasonably good level, we need to go even further in our total COP or kilowatt per ton. Next slide. So when it comes to air handling units, what are we talking about? How are we going to make our air handling units more efficient? So some of the things are shown on the left-hand side. A lot of the designers and consulting engineers are every day bothered about this, and we have direct outside air systems, we have radiant cooling systems, we have evaporative cooling systems. But what we are going to talk about is the normal air handling units, the recirculation units in our offices, hotels, hospitals, and other places, which almost form 60 to 70% of the market. So the first and foremost thing that comes to our mind is the addition of recovery systems. Till now, in our recirculating air handling units, we are not really making use of the recovery systems. If we have to reach those good numbers, we need to put heat recovery systems in order to capture whatever we are exhausting. We have to use more efficient fans. We have to use more efficient motors. Wherever the frequency inverters are there, we must make sure that they are up and running and working. And I will come to the next 3 points, which are of great importance. And that is where we are saying we are talking about new pathways. And that is decreasing the pressure drops, decreasing the velocity, and to some extent, increasing the size. And if we have to increase the size and get our energy down, then the most important players are the architects and planners of the HVAC system today. Because a lot of the places, the HVAC contracting or the HVAC consulting team faces this issue that they are boxed into a corner as far as air handling units are concerned. And this eventually plays on your total cost of ownership. You might think that you're buying a small AHU at a lower price today, but over a long period of time, if you do your total cost of ownership, or life cycle cost analysis, then you will find that you would have been better using a lower velocity air handling unit rather than a higher velocity air handling unit. And this is what we are going to show you in the next few slides. Next. So let us look at what is the saving or what is the benefit we are looking at. Lighter to heavier buildings, it's 1 kilowatt hour per square meter per year. More insulation goes to 3. Better windows, it goes to 5. But when you go to low speed HUs and better efficiency on HUs, you are talking about 7 to 16 kilowatt hour per square meter per year saving on a total which exists today anywhere between 70, as claimed by some of the software companies, to 120, which is the normal practice. So it's a big number. And it is a must if we have to get to net zero buildings. Next slide. So here are the slides on life cycle cost analysis. All of us know that basically the investment cost, the first cost, is only a minuscule portion of the total pie. Your investment is 10%, your maintenance is 5%, your running cost, energy maintenance, is approximately 90% of the cost or the money you spend over the life cycle of these particular products. So if you bring down the energy costs, you bring down the life cycle cost. And here are the software solutions developed by one of our important partners, the Flat Group, where you run various simulations and you get your output on the right-hand side of the screen as to what size, what velocity is getting you how much saving, what pressure drop reductions are getting you how much saving. Even when you come to basically the type of wheels, this particular software takes into account where you are running this particular air handling unit. The reason being that the most efficient of wheels in a hot and humid climate may not be the most efficient wheel where the heating demand is higher. So one place you might be using what is called a sensible wheel, whereas at other place you might be requiring a higher pressure drop enthalpy wheel, which will go into absorbing moisture. So let's go to the next slide. So again, we have on the top, you can see, go one slide back, we have shown something like A plus, A, C. So there are various classifications you can do. And by these classifications, we basically mean that these are the energy class of the air handling units. And you get your energy class before you produce the air handling unit by doing these particular simulations. Next. You then run on the first cost and the operations cost of the different classes. And now you can make out what is your payback period. So obviously, as you can see, the cost of a class C unit works out much higher when it comes with the number of years of operations. That means A plus may cost you more as a first cost, but A plus at the end of the life cycle of, next slide please, Next. Next. Okay, go one back. Yeah, so including the first cost and the operations cost, a A plus energy class unit will obviously cost you lesser over the life cycle of the unit. And these are detailed calculations. Even when we spoke to the previous speakers, I'm just saying you could hear at times that these are costs that we are adding to our systems to make the systems more efficient. But end of the day, the person who buys it, he needs to wait properly to see if his life, if he's getting a payback in certain number of years or not. So most of the equipment today onwards that will be sold as high energy classification equipment going into lower and lower energies will require something called life cycle cost analysis. Next slide. So let's look at some things. How are we making these particular air handling units more efficient? The first thing is direct drive fans, that is plug fans or fans with EC motors. And these have total efficiencies which are much higher than belt-driven fans today. So these are taken into account when we do the NCO calculation for our energy efficient filters, for energy efficient fans, and these are the new part of the new pathways. Next slide, please. So on this slide, you can see how high the energy efficiencies or the motor efficiency is for an EC motor. That is your topmost line, the blue line, the red line, and at the top, the green line that you see is a new technology EC motor. You have an array of new fans substituting the old centrifugal fan and thereby increasing the efficiency of the air handling unit. It may be at an added cost, but as far as the payback is concerned, you have a payback finite number of years that makes it justifiable. Next slide. Thing to remember is that if you need to keep your equipment operating at high efficiencies, you need maintenance space. It is not possible to maintain an equipment's efficiency levels unless proper maintenance space is provided. And Eurovent has built into its programs these particular things to make sure that any certified equipment by Eurovent or Eurovent certification takes into consideration these spaces and accessibility. Next slide. So how do we ensure these things? The selection software is checked and we do a data mining. And that is one of the most important things in our certification process. We do a lab testing of sample units. As you understand that it is not possible in the air handling unit world to check each and every unit, but we pick up the sample units and we get them tested in multiple labs to make sure that whatever is being certified by us is giving the true capacity in the field. Next slide. And we also do a factory audit to make sure that whatever is selected and put into the air handling units in the various certified equipment is in compliance with what was shown on the test units. So that's where these three things form our backbone of certification and putting our label on these particular units. Next slide. So the bigger picture of airside is efficient airside system design and evaluation tools, energy efficient and energy certified airside equipment, proper airside installation, certified commissioning and operations training and HVAC components energy tracking. It's only when we go through this whole gamut of things will we be able to say that we've done justice to bringing the airside energy down. And if we use the other things also that we heard about earlier in the program, we really have a way of bringing the overall energy of HVAC systems down. As a result, the energy of the overall buildings down and approach net zero and decarbonization in a proper manner. So let us look at just a couple of new pathways that our friends talked about. And the first one was nanofluids. Nanofluids are great as far as district cooling and other applications are concerned, where we have a 9 degrees C delta T on the loop. And if you have to provide that 9 degrees C delta T on the loop, it will be very important to make sure that even when you go to part laminar flows, your heat transfer is as good. So I'm sure that will come in use. When it comes to the second presentation, and you're talking about energy storage, well, that is going to be a major component in bringing down our overall building energy, because if we shift on big jobs to district cooling, then if we do not produce the desired delta T on the loop today, district cooling companies talk about penalties. You can never talk about penalties to a customer. So that particular delta T, which is not met, can be used as the first stage of cooling to produce ice and store within the buildings. Or you can use these heat storage fluids and store the cooling within the building to tide over the time when your energy costs are high. What you can also do is that when your solar production is high, if you do your life cycle cost analysis properly, that will come out as a good source of storing cooling. So that's from our side, basically, these particular things which lead you towards labeling and classification of various kinds of air handling units. And you can see the air handling units can be classified from A to E. There are various factors which lead or get you those energy numbers. Some of them are lower air velocity, higher heat recovery efficiency, fan efficiency improvement, etc. And on this slide, you can see that even the Indian standard, the ISHRE Rama standard, has come up with a similar requirement for classifying the energy efficiency of air handling units, which might become prevalent in time to come once we are able to basically do the lab testing of these particular HUs in India. So that's all from our side. Thank you very much for the time. And we are here to answer any questions in time to come or at the end of this program. Thank you, Santosh.
Thank you, sir, for this wonderful presentation. So the participants can raise your hands if you have some queries or questions from the speakers, and we will allow you to speak. We'll unmute your mic, and you can ask.
Also take up the questions that are in the chat box first, then maybe we can unmute.
Yes, Mr. Siva Kumar, you.
Happen.
Yes, you can unmute and can ask your question. Mr. Siva Kumar, you can unmute yourself. We have allowed you.
Mr. Siva Kumar, please unmute yourself and ask the question, please.
If he has already posted it, maybe you can read it.
Meanwhile, we have a question from Ayan Sen Gupta. So the question is, use of PCMs are popular in Europe and the US. What is the scenario in India? If I talk about Indian supermarkets, are PCMs being used for peak load saving? What do you think can be the possible reason for not having widespread usage of PCMs in India? So, Mr. Bhuvnesh, you please
Yeah, sure. So, majorly some of the applications which are like used in Europe, that is because of the mandate also, which their government has done. Basically, as I like tell you about the heat pump application or the heat battery application, that is because of the mandate which government has brought. But recently, you might see some of the application, PCM application in Indian scenario also, like the heat pumps are used in the northern states of India. They like in Ladakh or Sikkim. So they have started using it in resorts or offices. And there are other applications of the cold chain, basically, which is very popular now. But like in future, we can see the more application of the PCM in India. But there are few scenarios where we cannot use the PCM in Indian weather, basically. So if I talk about the HVAC using ceiling pouches in the false ceiling, that cannot be used in India because of the temperature variations, which India is not having. It requires diurnal temperature variation. So that is not possible or feasible in Indian scenario. So almost all the applications which you can see are possible and feasible in India, and people have started opting it because some of the applications were like cost intensive initially, but now you can see like the cost of these solutions is competitive to other alternative solutions as well. So it is catching its pace slowly. Yeah. Thank you.
Thanks, Bhuvnesh. The next question is from Mr. Ramesh Kumar and to the Hydromx. Maybe Mr. Mahin or Berkin can answer. So the question is about like, can we use Hydromx in heating applications like for the heat pumps or the industrial heating? That can
Berkin,
be
are you there? Would you like to answer? Should I answer?
Yes, I'm here. Yes, as a matter of fact, we're using in New York all the bunch of heat pumps. In the UK, it's in the heat pumps and also in boilers. What we have to do is for heat pump applications, depending on the freeze point requirement, whereby the heat pumps is designed for, we have to adjust the glycol concentration. But the short answer is yes, it can be used, as a matter of fact, in even heat recovery loops. In the UK, we have 2 hospitals over, say, 20 heat recovery loops being replaced with heat pump. I mean, with Hydromx, where there is no heat pump or no boiler or no chiller, it's just fluid circulating to recover the heat.
Thanks, Mr. Berkin. The next question is again to you, Mahenji, and the question is about from Mr. Mallikarjun. He's asking about that how do you convert the savings into CO2 avoided emissions?
So as a principal rule is when we say that Hydromax, when used with water and in a closed loop system, whether it is heating or chilling, it guarantees a 20% savings. We've seen cases where it's gone up to 30, 35. So every unit of energy saved results into about 0.8 kgs of carbon emissions reduced. So the math is very, very clear. So whatever energy efficiency is obtained by using Hydromax, a 0.8 multiple of that is the carbon emissions in terms of kgs reduced. So yeah.
Thank you, Mr. Mahenji. The next question is from Prithvi. And the question is about great airside optimization presentation and insights of LCC. What do you think about the potential of water-based systems like radiant cooling or floor cooling in India? As water can carry more thermal energy and very common in Europe. So,
yeah, so it is already being tried in India. You can see the great building done in Gujarat, which is a sample building for all of us, where floor cooling has been incorporated, and it has resulted in energy savings. When it comes to radiant cooling, be a little careful, because don't apply it in very humid areas, because the load will then get transferred to direct outside air unit. You have to do good measurements between EOAS system and the radiant cooling system as to which one is carrying how much load. And in the hot and dry regions of our country, radiant cooling is the second preference after evaporative cooling. And I hope there comes a day when evaporative cooling in India, especially in the hot and dry regions, becomes mandatory. That means just like the use of economizers in the United States, that till such time you can cool a building with an economizer, you don't switch the compressor on. So similarly, till such time in a hot and dry region, you can survive or you can cool with evaporative cooling systems, you should not be resorting to chill water. So yes,
Yeah.
these are great systems.
Mr. Malikarjun again raised a query, and it is to you, Mahenji, that what is the CO2 emissions for nanotechnology? And it can be offset directly by computing on savings.
I'm sorry, I'll let Berkin. Berkin,
So
can
I'll
you
repeat
please
that.
address this?
It is
I missed the question. Can you please repeat the question?
yeah.
Yeah.
So it is what is the CO2 emissions for nanotechnology, and it can be offset directly by computing on savings. I don't know. It is a suggestion or a question. I don't.
So I think the question is referring to embedded carbon.
Offsetting what again? I couldn't quite make the question. I'm sorry.
So we can unmute you, Mr. Malikarjun, if you are there.
What are we offsetting with nanotechnology?
Embedded carbon.
Embedded carbons in the nanotechnology. Malikarjun, can you raise your hand, and then we will be able to unmute you. Yes, thank you. And here you go. You can unmute and raise your query. Yes, Malikarjun, go ahead. I think your mic is not working. You can recheck and. Meanwhile, we will take the query from Mr. Sandeep. Sandeep, we are unmuting, allowing you your mic, and now you can unmute and raise your questions, whatever.
Yes, for Hydromx, am I audible?
Yes.
Yes, now.
Yeah. So first of all, thank you for an excellent presentation to all the speakers. My question is for Hydromx. So the performance improvement from the use of these nano fluids that we talked about, can this be certified by certifying bodies like AHRI or Eurovent? Is there a discussion going on that front?
So we have no. So we haven't had any body certifying the savings, but as we as a process, what we follow is we do a pre and a post measurement verification of the units consumed, the parameters, the capacity utilization, etc. There are multiple data points which are collated before and after, which kind of justify the savings that is being deployed. That's a similar case study for, and post that is being done. There's a case study done by an approved engineer, which gives the required saving that has been achieved. Of course, it is verified and accepted by the customer also, and yeah, that's how the verification is done.
If I might just jump in for 1 second.
Sure, please.
Thank you for the question. Yes, in fact, we do have certified definitely results, not only by the end user, but also by third-party independent organizations that is approved by the agencies like U.S. Green Building Council. So whereby we do also have a environment product declaration document published by NSF itself, and NSF is a program operator for LEED and U.S. Green Building Council, which can be easily found out online, just nsf.org, and you can search for Hydromx, and you can see the environment product declaration. Not only that, when I mentioned the biggest retrofit project for converting the fossil fuel boilers to heat pumps, actually in the world, that is, and New York City has been chosen as the pilot city, and Empire State Building has been chosen as the pilot building. That project is going to be looked at by literally every agency that is going to use the electrification movement, converting fossil fuel boilers to heat pumps. I know this is not applicable in India, probably 99% of it, but it's just the fact that I had to feel like it had to be mentioned.
Sorry, one more thing, Berkin, if you could add. I believe if you're using Hydromx as a solution, LEEDs does help you get some additional points for certification, right?
Oh, absolutely. That's why I did mention the environment product declaration, which comes with the LEED points if you have the lead engineer specifying Hydromx. The difficult part is the LEED projects is if the project has been assigned, or if you specify a Hydromx at the construction phase, it creates a lot of question marks because the technology is not the product that we're introducing to the world. Maybe I should have mentioned that earlier. It's the technology that we're introducing, and if this technology was offered by, let's assume, Dow Chemical, right? Nobody would ever question it. Right? Let's face the blunt truth. Since we're too small of a company, we're growing rapidly, although we're too small for this technology. That is why questions arise time after time, and our facts is the data that we provide of our end users. For example, Verizon. I don't know you are familiar with Verizon. Is the world's probably top data and cellular provider, and they already started to use in their 6th data center, and after seeing the data time after time after time. But if you were to ask them, okay, can you give us a white paper on it? Well, they will not give you anything because of the NDA restrictions. However, they keep ordering it for all their sites. I hope that answers the question.
We are running late of the time, like we already exceeded 7 minutes, but if speakers allow, we can take a few more questions in next 3-4 minutes.
Please do so.
So, Prithvi, I have allowed you mic. If you have any question, you can unmute yourself and then raise.
Thank you so much, everyone, for great insights towards various cooling applications. I'm Prithvi. I'm a sustainability and working as a decarbonization projects across Europe, especially with the Netherlands for the past 4-5 years. And we have a lot of technologies when it comes to heating, and there are many more I often see in conferences. And I would like to explore more on what are the technologies that we have for hot and humid climate, especially. And do you see an application of desiccant-based indirect evaporative cooling in India?
Yes, sir, you can.
Okay, Prithvi, excellent question. Desiccant wheels have been over here for a long, long time. Some of the companies have done wonderfully well with desiccant wheels over here. In old times, there used to be chemical desiccants, dehumidification, which were popularly known as Catabar and things like that.
Mm-hmm.
And there's a lot of research on this particular area. And like you mentioned, evaporative cooling. Evaporative cooling is growing in the country by good percentage between year to year. Combining it with desiccant wheels is something which has not been seen very popularly over here in terms of applications and projects. So that's where we stand. But the younger generation research work is a lot on evaporative cooling and on the use of enthalpy wheels or other kind of dehumidification products. I hope that answers the question.
Thank you for the answer, actually, because the more and more I see in the field, or especially across the projects for renovation projects or for new projects in Europe, it's always about heating, and there are always smarter solutions or sustainable solutions to produce heating. But cooling is always trickier, and cooling, especially in hot and humid, is the most challenging tasks ever.
Can I just add one thing? So Eurovent has come out with a hot and humid certification separately as compared to heating certification, understanding this particular challenge. And things are being, a lot of work, if you look at Portugal, is being done on hot and humid climates in Europe.
Yeah.
And we assist you in getting 1:1 with these great guys who are working on hot and humid climate within Europe. Thank you.
Yeah.
Mr. Mallikarjun, we have allowed you the mic. If you have a query, you can unmute yourself and you can raise the question.
Thank you a lot for the answer.
Yes, thank you. Mallikarjun. Okay, so let me say if you have any other questions. So that's all. If you have any further queries or questions to the speakers, you can write to us and write to us, and we will pass the questions or queries with the speakers and will return to you. So here, thank you all the participants and the speakers for the wonderful presentations and the wonderful question and answer session. My colleague Riva has a announcement for you all. Riva.
Thank you so much, Santosh. Thank you so much to the esteemed panelists, Berkin, Bhuvnesh, and Prabhat for sharing their valuable insights, and to the participants for an amazing round of Q&A. This webinar is one of the many organized under the India Cooling Coalition Cool Tech series. So please do keep an eye out for an email following shortly containing the session recording and a link for the feedback. We look forward to your inputs on the topics that you'd like to explore in the future series. We would love hearing from you. Thank you so much for being